All right, guys, on the slide, you see a picture of a house. And if I were to ask you where you live, you would probably give me just the address, right? What if I were to tell you, though, that I lived at, right, that says like 4112, right? 4112 Smith Street, second floor, third bedroom on the left, right? I then got really specific about what my address was. All right, and so today we're going to be looking at how you can get super specific about the address of an electron. Okay, so today's objectives are you're going to be able to identify an element based on the S, P, D, and F blocks in your periodic table, and you're then going to be able to determine the full and shorthand electron configurations of an atom or an ion. So, we know so far about electrons are that they want to be near the nucleus, right? So they're attractive to the positive charge of the protons that exist in the nucleus. And those that are the closest are going to have the lowest potential energy, meaning they're going to have the lowest energy compared to the overall, all of the electrons, right? However, electrons want to be away from other electrons, right? If you think about a magnet, if you put two negative sides close to each other, right, they're going to repel against each other, okay? So they want to be far away from other electrons, but close to the nucleus. And the space that electrons have to move around increases the further you move from the nucleus. Okay, so the further you move away, the more space you have. Okay, so fewer electrons can exist close to the nucleus because it's space limited, and more will exist further away because there's more. Okay, and we've learned about the Bohr model already for the past 3 days. Okay, and we know that there are principal energy levels. Okay, we've seen those. Those are my rings around my electron, or around my nucleus, and this is where a certain number of electrons can be expected to be found. Right? We looked at N1. We saw that we had a total of 2 that could be found here. N2, we said there was a total of 8. N3, we said there was a total of 8. Right? That's going to change a little bit today, but don't worry, it won't be too hard. Okay. But not only do we have principal energy levels, but in those principal energy levels, we have sublevels, okay, which are patterns of movement for electrons within the principal energy levels themselves. And their variety and number will increase as you move away from the nucleus. Okay, we have 4 types. We have an S, a P, and a D, and an F. Okay, an easy way to remember this is the acronym. Some people do forget. All right. And so what I'm going to have you guys do is I'm going to have you fill this chart out, and then I'm going to explain it. So pause and copy. All right. So when you look at your principal energy levels, right, and 1, 2, 3, and 4, okay, if I am in that first energy level, so the closest to the nucleus, I'm only going to have one sublevel, and that sublevel is S. Okay. An S sublevel holds a maximum of 2 electrons, and so overall that level can only hold 2. Okay. As I move further out, right, my second energy level, I'm going to be able to hold 2 sublevels, and those 2 sublevels are S and P, so I just gained a sublevel. Okay. Again, S holds 2 electrons, but P now holds 6. So my second energy level as a whole will hold a maximum of 8 electrons. Okay. Now we move on to 3. Okay. 3 will have 3 sublevels. You guys can see a pattern going on. And those sublevels are S, P, and D. Right? So just as before, S holds 2, P is going to hold 6, D now holds 10. So my overall third energy level will be able to hold a maximum of 18 electrons. Okay. Next is my fourth, has 4 sublevels, S, P, D, and F. Okay, so we added the F, so same as before, S, P, and D still hold the same amount. F is going to hold 14, so I can have 32 total in my N equals 4. Okay. We talked about at the very beginning of this lecture, right, I could be super specific about my address, right? And that's pretty much what electron configuration is. Electron configuration is a way to show how electrons are ordered in an atom, okay? And it's a specific way in which atomic orbitals are filled. So each atom can be identified by this configuration, okay? The big number 1 tells me what energy level I am in, okay? Whether it's 1, 2, 3, or 4, right? Those circles from the nucleus moving out. My S tells me what sublevel I'm in, so whether it's S, P, D, or F. And the 2 exponent tells me the number of electrons that occupy this sublevel. Okay, so this is saying I'm in my first energy level, okay? I'm in my S sublevel or my S orbital, and I have 2 electrons total that are going to be in this sublevel. All right, so now that we know what electron configuration looks like, right, so that like one little individual, we can now start to chain them up to make the full address. And I have 3 steps in order to do that, right? So step 1 is I need to identify the element that's on my periodic table. All right, that's wicked simple. You guys should know how to do that by now. Okay, my next step is then I'm going to follow my periodic table from left to right across my periods, okay, until I reach that element. Okay, my last step is then I'm going to count how many elements I have crossed in each block, okay, which signifies my subshell, and that is going to be your exponent. Okay, so I'm going to work through an example with you, and then we're going to do practice problems. All right, so I have aluminum here. Okay, that's what I want to write my electron configuration for. Okay, I have highlighted an S, a P, a D, and an F block for you. Okay, I want you guys to do the same thing on your periodic table that is printed out for you. Okay, and my first step is to identify aluminum, which I have boxed here. Okay. My second step is to go across each row until I hit the element I want, right? So I'm going across this period, across this period, across this period, and I'm stopping at aluminum, all right? Then to write my configuration out, okay? This is what it's gonna look like. I go across and I say what subshell, what energy level, what subshell, and how many electrons are in each, right? So here I see 1s, 1s, right? So I'm going to write 1s, and I have 2 1s's that I filled, so my exponent's 2. The next one I do is a 2s, right? So 2s here, and I have 2 in 2s, so I put a 2 here. 1, 2, 3, 4, 5, 6 elements in 2p, so I have 2p6. Then I have 3s2, and I end in 3p, and I only filled in 1, so my exponent's going to be 1. All right, so that's how I'm going to do my electronic configuration for aluminum. All right. But what about the opposite? Okay. What if I have an electron configuration and I want to know what my element is? This one's a little bit simpler. All you need to do is you need to find the last section, right? In this case, it's 3D3, right? Go to the section that's 3D and count 1, 2, 3 in, and it is vanadium, element V. Okay? Super simple. So what I want you to do right now is I want you to pause the lecture and I want you to complete these 6 problems in your worksheets. Okay? All right, so next we have noble gas configuration, and this is just a configuration based on the noble gas that comes before an element, right? We call this shorthand notation, okay? So it's going to shrink my overall electron configuration. So my first step is the same as the one before. I'm going to find my element on my periodic table. Okay. I am then going to go back to the last noble gas that was found or passed. Okay. I'm then going to write that symbol of the noble gas in brackets and then continue on with my electron configuration until I have finished it up, right? Until the row, using the row after the noble gas to finish it up. Okay. So let's look at this example here, right? I have iodine. This is my full electron configuration, right? Step 1, we said, was to identify my element, right? Step 2 is I'm going to go back to the one that was passed, okay? And the one that's passed is just going to be up one row all the way to the right. So up one row all the way to the right. So in this example, krypton is the last noble gas that I passed, right? So I'm going to put krypton in brackets and then finish up with my noble gas configuration, right? So I see krypton in brackets, right? My chemical symbol in brackets, right? After krypton, we see that we start with 5s, and I have 2. Then I go to 4d, I have 10. And then I'm in 5p, and I go 1, 2, 3, 4, 5. And I have 5 in my 5p. All right. So now what I want you to do is I want you to pause the video, and I want you to do these 4 practice problems in your worksheet. Okay. Now that you have completed this lecture, what I want you guys to do is I want you to A, write a 3 to 5 sentence summary, B, work on your practice worksheet, and 3, take the Mastery Connect quiz. The code will be on the board. All right, so that is it for electron configuration. We're going to look at it more tomorrow and finish it all up.